With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, so the question is a constant power is applied to a rotating disk. Now we have to find here the relationship between the angular velocity omega of the disk and the number of rotation n made by the disk is governed by. So let's look at the solution. So actually in this question we have to find the relationship between angular velocity omega and rotation of the disk. Okay, so for this let us say the above disk is rotates with angular velocity of omega at time t if the disk is supplied with a constant power of P. Then energy E acquired by the disk is given by E is equals to P into T. Let this to be as equation number 1. Okay. Now in our question it is given that the disk rotates, hence the power supplied to the disk will get converted to the energy of rotation. If I is the moment of inertia of the rotating disk, then the energy of rotation is given by E is equals to 1/2 of I omega square. Let this to be as equation number 2. Now if we equate equation 1 and 2, we get P into T will be equals to 1/2 of I omega square. Okay. Now we differentiate the above equation with respect to T, that is d by dt of P into T, that will become is equals to d by dt of 1/2 of I omega square. So if we differentiate it, so we get P will be common while dt by dt will become 1, that will be is equals to 1/2 of I will be common, and derivative of omega square will become 2 times of omega into d omega by dt. From here this 2 will be get cancelled. We get d omega by dt will be is equals to P upon I into omega. Okay. Now in order to express the above equation in terms of number of turns of the disk, let us multiply and divide the above equation by small change in angular position, that is d theta. Hence the above equation will be get reduces to d omega by d theta into d theta by dt, that will be is equals to P upon I into omega. Now we know that d theta upon dt is equals to omega. So from here we get omega into d omega by d theta will become is equals to P upon I into omega. Now I will take omega to that side, so it will become omega square d omega is equals to P upon I into d theta. Okay. Now let us say the angular velocity of the disk is omega when the angular position is equals to 2n pi, where n is the number of rotation of the disk. Hence integrating the above equation we get, that is integration of 0 to omega square d omega, that will be is equals to theta from 0 to 2n pi P upon I into d theta. Okay, so after integrating this we get omega cube divided by 3, that will be is equals to P upon I will be constant, and here integration of 1 will be theta from 0 to 2n pi. So after putting the limits we get omega cube divided by 3, that will be is equals to P divided by I into 2n pi minus 0. Okay, now if we take 3 to that side, so omega cube will become is equals to 3 to the 6. Okay, this will become n into p upon I into 6 pi. Now if we take cube root on both sides, so this will become omega is equals to n raised to 1 by 3 in bracket 6 pi p upon I, that bracket raised to 1 by 3. Now according to question, we have to find here the relation between angular velocity omega and number of rotation n. Okay, so if we see here, so this term is the constant term, hence omega will become directly proportional to n raised to 1 by 3, and this is what our required answer. So if we see here, the power of the rotation, that is n, is 1 by 3. So according to this, option A will become correct answer for this question. So this is the required solution. I hope you understand. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.